Hello. Maybe a quick question. Who likes JavaScript? Okay, maybe I should say, is anyone willing to say they don't like JavaScript? Okay, I appreciate it. Okay, why does this group like JavaScript? What's good about JavaScript? Anyone?
It's very forgiving with type coercion and the way to interpret everything. Can be very easy language to pick up with, but very hard to understand the nuances of it. Yeah.
So the type coercion thing, you view it as a bonus.
Yes.
I view it as the bane of my existence.
Seriously, it's forgiving. It's trying to make the best of what it thinks you're doing. It's a nice language.
Yeah, I mean, I'm glad that people appreciate it.
Would you rather the VM hang and crash your whole application?
It's yeah. So the type coercion is the bane of my existence. It makes everything fun just terrible. But yeah, I mean, so okay, type coercion. What else?
It's ubiquitous.
Okay, ubiquity, right? It runs everywhere.
It is everywhere.
It is everywhere.
It's the glue that holds certain applications together.
Yeah.
Okay, so I'm hearing a lot of Stockholm syndrome here, stuff with it. Okay, so yes, you're required to like it.
It's a dynamically typed language, so you're able to do a wide gambit of different objects, different values.
Okay. All right. Flexibility. It's a dynamically typed language, very flexible. You don't have to fight with a type system. Sorry?
It's JavaScript. You're not going to get much more from us.
No. Okay, so the things that I'm surprised I haven't heard anyone say, it has first-class functions. Compare it to Python and Ruby. It has first-class functions. It has real first-class functions. Does everyone know what a first-class function is? Is anyone brave enough to raise their hand and say they don't? Okay, I'm awesome. It's exciting. I have to explain first-class functions. So in JavaScript, you can treat a function just like any other value. There's nothing special about a function. The syntax to call a function that you give by name versus a function that you took as a callback, it's the exact same. I had issues with Ruby because sometimes you need square brackets and sometimes you need round brackets and procs and lambdas and stuff, and it was making me go insane. First-class functions. Okay, what about speed? JavaScript is fast, right?
The renderer it's under could be fast, like V8 or Bun. When you go after the runtime, like Node.js, that can be fast, but usually it has to be interpreted, so it's typically slow relative to compiled languages.
So, just a temperature check here. Is JavaScript about as performant as Python or Ruby? Is it faster? Is it slower?
It's faster.
It's faster.
Faster
Okay.
than Python.
What about Swift?
It's not as fast as Swift.
It's not as fast as Swift? Okay, what about Java?
It can be. It can be as fast as
It
that.
can, yeah. It depends on the runtime. If you look at the V8 dev channel, they do a lot. Like they've pointer compression now, and there's a lot of stuff. So.
Awesome. Okay, so I'm glad everyone likes JavaScript. Otherwise, this talk would be very embarrassing. So I actually don't really know JavaScript that well. I'll be honest. I worked a little bit as a front-end developer, back when I was an intern or something, but I don't actually know that much about front-end development. I do, however, know a little bit about the JavaScript engine. So if in your mind you're thinking, oh, I hate JavaScript, I think everything that I say in this talk also applies to Python and Ruby. They all do the same optimizations under the hood if you use like PyPy or something like that. So hopefully, there's not too much intense JavaScript here. Hopefully, it should just be applicable to these other languages as well. So here's a little description of the talk. I've drawn a diagram to explain it. So I'm going to just give a little bit of an introduction, a quick little demo, then we're going to dive into some disassembly. We're going to see how the JavaScript actually gets executed on your computer, and then I'm going to spend a bunch of time explaining it. It's like approximately the amount of time I'm going to spend. So first of all, who am I? I'm a cat. What is JavaScript? No, sorry. So my name is Justin. I went to school in Ontario, grew up in Ontario, and now I'm here with my partner who's here tonight. I work for a consultancy called Igalia. It's an open source consultancy, globally distributed, 100% remote, which means that I never get out of the house, except for the Dev Edmonton meetups. And that's our cat.
What's
What's the cat's name?
Dorian.
Dorian.
So, okay, another poll. Who knows the novel A Picture of Dorian Gray? Oh my. Okay, so I'm just the one who doesn't.
Who's actually read it?
Yeah, that's another question.
Okay, so it looks like it's just me. Okay. So okay, we know what JavaScript is. I found some random JavaScript on the internet. This is a problem, you know. Don't let me find random JavaScript on the internet. I found some random JavaScript on the internet. This was from like some random leak code solution. Someone generously gave the solution, and then I stole it. This function, I don't think the actual details here, you know, it's a big wall of code. It doesn't really matter. The important thing is it does some array stuff to figure out if a Sudoku board is valid. So, you know, it doesn't. You don't have to worry about how it works. Just like it is some code, and I found it on the internet. I didn't write it, so I couldn't have. You know, my sneaky brain couldn't have been trying to make something that was going to work especially well in my engine or anything like that. So, what is int data rate? Does anyone want to offer a? Does this look familiar to anyone?
It does, because I've been like doing like primitive types and whatnot. But I don't really. I'm not strong enough to give me explanations.
So, an int data array is a kind of typed array. Voila, lovely MDN. JavaScript has regular arrays. A regular array can hold anything. Like we discussed, it's a dynamically typed language. You could put strings, numbers, doubles, whatever. Anything can go in a regular array. But that means that when you want to read from the array, you could read anything. So if you know that you're expecting to read an int all the time, why make the space to be able to store an object or to be able to store a string or whatever when you know that you're just going to store a byte in there anyway? So typed arrays give you a bunch of different kinds of containers. And they're really fast because you know that it can only store, in the case of an int data array, a byte. So that's a typed array. This is how you use it. In this demo, we have this Sudoku solver. It's going to have an array that's going to store the board. And the question is going to be, should we use an array, that's the first line here, or should we use an int data array? Anyone? Which one's going to be faster?
Int data array.
Yeah. How much faster? That's a much harder question. Is it going to be twice as fast? Is it going to be 30% faster?
8 times as fast.
All right.
Is this like a Price is Right?
I mean, sure, let's do it. Price is Right rules. Call it up. 8 times as fast?
8 an hour, and you know what? It's simple.
Okay, we have 8.
7.
7. 7, okay. Okay, well, we'll see. We'll see. So,
like 0 or whatever.
the idea is I have this right here. I'm going to give a little demo. I'll walk through the demo code, but essentially we're going to fill out this chart together. So we're going to establish, like, yes, int data array is the fastest. I'll give you that. So that's 1, and then we're going to measure the relative speed up. In this case here, there's 2 phases. So the way that this little micro benchmark is going to work, this isn't what real code looks like. You know, it's just, I want to show you, you know, this particular example. But you have the first phase and the second phase. In the first phase, you're going to initialize the Sudoku board using the thing in the left. Then in the second phase, you know, the second call. So for example, if you initialize it as an int data array, and then you reinitialize it as an int data array, you get performance 1, we'll say. So on my computer, it's going to be like 270 milliseconds for this little snippet of code. And the idea is we're going to see what happens when we mix it. So time to make some predictions. So if I start with an int data array and I continue using an int data array, we go the fastest. If I use a regular array, we think we're going to go 8 times slower? 7 times, 6 times slower? We have Price is Right rules?
Yep.
Okay.
Sticking to it.
Now, we agree that int data array is going to be faster than array. What happens if for half of the benchmark we use an array, and for half of it we use an int data array? Is that going to be slower than either? Is that going to be somewhere in the middle?
Depends.
You think middle?
I say array to int array is going to be faster, but int array to array is going to be slower. Let's see if I can go.
Okay. So one of them is going to be faster, one of them is going to be slower. Your stunned silence is very reassuring. We'll find-
I'll
okay.
give it a shot. I think if the developers, are you testing with V8?
I'm going to test with JSC because that's what
Okay.
I work on, but
Okay.
the results
Oh,
are true
hey,
for
did
V8
you
as
work on JS? I forgot.
well.
Okay.
So I
well,
think I should have mentioned
I
that.
assume you're very, very, very clever. And so I'm assuming that if you, like, there's a way, if you already have an int data array 8 array and then go to a regular array, that you can make them base practically the same speed.
Okay. So you think they're going to be practically, but not exactly the same speed?
Yeah.
Okay. So int 8 array to array you think is going to be somewhat graceful.
Yeah.
And then array to int 8 array you think is not going to be as graceful.
Alright, so the opposite of what I was saying.
Yeah.
Nice.
Okay. So we got some predictions here. Okay. Now it's demo time.
Well, and there's probably messy things like.
Well, I'm thinking like garbage collection because there's like the old gen versus new gen.
Absolutely. I have written the benchmark to explicitly do collection outside of the measure time.
Nice.
We can remove garbage collection from the equation here, which might not be fair. In fairness, you're going to see it's unfair in one of the other comparisons that I'm going to give, but it's not part of the measure time.
Yeah.
Let's see here.
Well, and it probably makes a difference too whether you write once or whether you are going and rewriting the board on the fly. And all these integers probably take up the same memory space, so it would be less of an issue compared to like if you were trying to put first names in or something.
I think this is getting to be, well, yeah. So I have this little benchmark here. I think the interesting part here, I have these list of configs. So we're just going to quickly test here based on essentially exactly the table that I showed you here. So I'm going to highlight this section right here. This is just the list of configuration options we're going to pick. True, false, just should use the int 8 array or not. It's just so that it's going to be easy, so that I don't have to type out every combination of these things. But I've tried it without this code, and it didn't make a difference. So we will either initialize the rows to be an int 8 array or to be a regular array. And then you can see we do the initialization. Sorry, it's jumping around here. We do the initialization, then we run 500,000 times. This is an important number because it's another thing that I'm doing to cheat here. I'm warming up the engine pretty substantially. So JavaScript is a JITted language. It's compiled just in time. So I'm warming up the engine like a lot before we're doing any of these tests to be extra. JavaScript is cheating, right? So just remember that. But we run it 500,000 times, then we initialize it again. We run it 500,000 more times. We do a collection. Then we run it 1,000,000 times and see what happens. So the idea here is that you're only measuring it once it's run. After it's already had an opportunity to spend lots of time optimizing and to figure out what your code is doing.
So are you just doing allocation, or are you putting anything into this array?
This, if we look at the actual,
Oh, so you do have boards that you're feeding.
Yeah, so we don't allocate inside this loop. There's no allocation, so that way we can remove GC as being something to worry about. We just set, stuff. So we have rows, columns, whatever. These are just Boolean values here. We set it to false. We have, the algorithm is, whatever. They're Boolean values, but, it's really only ever true or false. So it just kind of works. So I have V8 here, so I'll run it just to show you. If I run JSC, you see my lovely local development build of JSC. We get that this hot portion after you've already warmed up takes about 265 milliseconds. If we run V8, we see it takes about the same, right? I think they're both pretty competitive with each other on something like this. So now, let's look at this config option here. This was using typed arrays. Don't worry about recording the numbers. I've already recorded it in the slide when I ran it. So we have this one here is going to be just using regular arrays. Is it going to be 6x slower? Let's find out. So it's not quite 6x slower. It is slower, but it's not that bad, right?
No,
Yeah.
2.
So it's not crazy. And I mean, yeah, V8 I think gets hit a little bit harder. But don't let me throw too much shade at the V8 developers because I picked an example that was really bad for JSC. Now here's the interesting part. So what happens? Okay, are we going to go faster? So let's start with V8.
Oh.
We go even slower.
Just do it again. I don't trust it.
And JSC.
No.
Okay, so the 8 was the wrong place.
It's
But the
slower.
energy is
So this is where you're doing.
Oh my goodness.
okay, maybe it's 8,000.
So okay, so I feel like when it got a little bit slower, that's your fault. When it got this much slower, it's my fault. So
Yeah.
we're working on it. I mean, yeah. we're gonna do
And
it.
this is using just array objects or typed array?
Yeah,
This is
reiterate.
mixing them.
Oh.
we
But
want
which
arrays-
direction?
Array first and then typed array?
So this one here was doing array first and then typed array.
And then type.
You know what? That makes sense. You said it, and then I was like, yeah, no, it's probably good. I was sticking to my guts.
So
Yeah, 8,000.
Oh
the
boy.
bane of my existence. Anyway, I did record how long it actually takes, so I think we can.
Do you have to control C it?
I think I might have to control C it.
Goodness.
It does finish. Like
Oh,
okay,
there we go. Hey.
Number.
Oh, that was the init.
yeah, yeah.
Okay.
So-
well,
okay,
that was
okay.
so much. That was much faster.
Yeah.
Is it mutating the array every time? Like when you copy to it?
Yeah, so we just reset the array every time. Like we just write false. But I think the actual reason here, we'll take a look at it. I'll show you the reason why it gets so slow in JSC. And then, just for completeness, I'll give you this one here.
Faster.
So, yeah, let's get a betting pool going. Okay,
Hey,
so,
Oh.
yeah, I mean, also pretty slow for V8, and I mean, also, yeah, JSC
Oh, yeah.
isn't as bad, but
Okay.
it's not having a good time. So, I mean, I like JSC. I think all of our data shows that if you take the happy path, JSC is a little bit faster than V8 based on the benchmarks that we use. So if you go to browserbench.org, those are the ones that all the browser vendors came together to agree on. And on that, I think JSC does a pretty decent job. I think that maybe some of these edge cases can sometimes, like I've definitely heard this anecdotally, like some of these edge cases can be a little bit worse in JSC. So it's worth thinking about.
Have you tried Bun, that runtime that like rewrote everything in Sig?
So Bun uses JSC under the hood for the JavaScript execution, but it
Yeah.
uses Zig for all the like Node APIs. I think the answer is yeah. Bun is great. We love Bun. So what we saw this is 1. This was about 1.7x slower, 22x slower. Oh my god, 6.3x.
well, okay, Dan.
So why? Why is that? Speculation. So I think you've probably heard of speculation before. Maybe you haven't heard it in this context though, because everything it's speculation all the way down. Like you've heard about like speculative execution, right?
Yeah.
Everyone, yeah, raise a hand. You've heard of speculative execution.
JIT and AOT and all that.
So yes, so I'm going to talk about the JIT like the JIT compilation speculation. But like your CPU is also doing speculative execution, which is also like it's not the same thing, but it's the same idea.
Idea, concept.
Like it's a really different thing, but it's extracting the same performance just at a different layer. And you want performance in depth, right? You don't just want to have performance because you have a really great compiler or because you sat and wrote really good code. You want like layers that are all working to give you performance. So speculation. First of all, I want to explain why I have such a long warm-up period. So if you're a piece of JavaScript, this is true for V8, Chrome, and SpiderMonkey, you start off in the interpreter. The interpreter is slow. It's not very fun to be in the interpreter. The interpreter is just essentially a loop that keeps saying, what's my next JavaScript instruction, then running. What's my next instruction, then running. So every single time you're doing this indirect branch, it's not fun. Very slow. So the natural progression is that once you've run code a little bit, you want to JIT compile it. So in JSC, we have a baseline tier. The baseline tier just stitches together these instructions back to back. So you don't have to do this jumping. Like you don't have to go, oh, what's my next instruction? Which opcode is it? You get rid of that switching completely. You stitch it back to back. That's the baseline JIT. Again, all the JavaScript engines have something like this. Then, if you run this code a lot more, you have this more advanced compiler called DFG. It stands for Data Flow Graph. So what this does is it can start to ask questions like, where does data flow from one place into another? Is this an integer? Is this a double? Is this an int 8 array? Like it starts to ask questions like this about types and propagate this information through. And then finally, we have FTL, which was faster than light or something. The acronyms, it's rare that you get to name an acronym, right? So I think people like to have fun with it. So this one here is like an actual proper compiler. It used to be LLVM, but LLVM was too slow. So they ended up rewriting it, and so it turns out that it's actually pretty easy to get a performance improvement because LLVM is so slow that it just takes too long to compile. And that's a common theme here. Everything about this is designed to trade off throughput versus efficiency. So if you try to compile everything in the highest tier right away, you're going to spend minutes compiling your JavaScript before you run it. Most JavaScript is run like one time. So you don't want to spend all this time and battery and energy spinning up your compiler and doing all of this really fancy stuff when it's going to be run once. It's just not worth it. So everything here is designed to trade off the latency versus the throughput. And FTL is at the top of that. Most code doesn't reach FTL when you're just browsing the web. Now, the other arrows here represent de-optimization, as V8 would call it, or we call it on-stack replacement. But the idea here is that all of these, like DFG and FTL, they make speculative assumptions about your code. So I'm going to explain in just a second what that is. But the idea is essentially, if it gets it wrong, that's fine, because it can always just run the interpreted version of it. It can always just go down to the tier that can handle all of the cases. So these upper tier compilers don't have to handle everything. So we have a JavaScript expression here. What does this actually end up doing? Okay, so first of all, are A and B primitive? If they're not, you have to like call to primitive on them. So that means, potentially doing a bunch of stuff in order to coerce them into a type that looks like a primitive type. If not, are they a big int? Then do big int addition. If it's a string, do string concatenation. And remember, this means that if one of them is a string, you have to coerce the other one into a string before you do the string concatenation. Otherwise, call to numeric. Now it's going to act like a numeric value. If this is going to look like an int32, and if that int32 addition would not overflow, do int32 addition. Otherwise, do double addition. Because in JavaScript, all numbers are doubles. They're always floating point. So if you keep adding past int32 max, you just keep going. It's doubles. But you may know that double addition is way, way slower than integer addition. So we always want to do integer addition whenever possible. It's way faster. So the other interesting thing here, if you look at this code, what happens between these two axes of x? Like if you put on your compiler hat, right, someone writes this code, well, you don't really want to have to go find foo.x twice, right? I think if you look at this code, you might just say, oh, well, I mean, surely you should just be able to read foo.x once and use the value twice, right? Wrong. Why not? Anyone?
Those two primitive numeric string things in A and B might mutate foo.x.
All those weird random things might mutate foo.x. Exactly. It can do a lot more than mutate foo.x. It can do something like you can install a new object on the prototype of window that like just makes it impossible for you to be able to know for sure where foo.x is without walking foo's whole prototype chain. This one is maybe a JavaScript specific thing. Maybe this one doesn't apply to Ruby, but it's a mess. For like, okay, Ruby developers, fight me, bro. Like, what are eigenclasses even? Like, these languages all have warts. It's just the price of being successful. So this can allocate, right? If it's string concatenation, it can allocate. So you don't know if if foo.x was going to be storing an object, maybe you want to write something to foo.x, then you have to think about how the garbage collector is going to be looking at this, right? There's that's a whole other talk. It can call a callback. It can call a callback. It can call a freaking callback. Like you can run like actual arbitrary JavaScript code in this place, and it can completely mutate foo.x. It's insane. This is the bane of my existence, because everything fun that you want to do, you can't do because it can just So what we actually want is A and B are int32. Yeah. Would it overflow? No. Do int32 addition. Otherwise, not my problem. And this code is way simpler, right? Like, this code goes super fast. And as long as it actually, hits most of the time, like if 1% of the time it overflows, that's fine. Like it'll just go to the interpreter, run that one, and then go back to the really fast version. So, ooh, fancy. This is what the JSC generated code. This is what the intermediate representation looks like. So I'm going to highlight the important part here. So in the bad case, inside our loop, we have to get the array length. And then we have to do a multi-get by val. What a multi-get by val means is you're gonna access like a value, right? So for example, foo.x or accessing an array element, that's called a get by val. So you're gonna get by val, but you have to consider that there's multiple possible ways that the target can look. That's why it's multi. So if there's one possible way, then you can do a really fast thing. But this means there has to be internal branching here. So you have internal branching in the multi-get by val, and you have to get the array length, because you can't just say, oh, well, it's always a typed array. I know how to get a typed array's length. That means you can't hoist that out of the loop. So one of the things the fast version of this code does, it hoists it out, so you don't have to run it inside the loop. You can run it once, and then you know for sure that you're always in bounds. So there's all of these fun optimizations that just get messed up because the types don't look the way that the engine expected. Here's the good case. So you see, since it's always a typed array, we know how to get a typed array's length. Trust me, that node, when it gets lowered, looks a lot better. And then we have the get by val, which is just one kind of get by val, so it's much easier to handle. There's no internal branching. I think maybe there's a big dump of information here. The important part is there's no internal branching if you just always have reasonable types. Type stability. So this is a good advice in general in life. Be stable. Be stable. Emotional stability is very important. So is type stability. If your program looks reasonable, then the engine will try its best to do reasonable things with that information. But if you start using I have a number, but then 1/5 of the time it's a string, and then sometimes it's a typed array because I have all the types, I paid for all the types, I should use all the types. No, it's not going to be able to make sense of that. And if you act in a really stable way, then it can make use of that information, and it can make your code go faster. So, it doesn't always do it, but it can certainly try. So I have a little comparison here. I want to give a number of disclaimers here. First of all, I don't know half the languages that I'm going to include in here. I did the shittiest ChatGPT conversion of it ever. So I think it's fine, but I could be missing something. Remember, this is not an exhaustive, benchmarking setup, right? This is on my computer one day at the temperature in the room, and if you cough on it the wrong way. So it's one use case, right? I think it's going to really highlight the importance of measuring your specific use case before making generalizations. So I'm going to include this because I did it, I was curious, and it was a little surprising, but please don't generalize here at all. This isn't ancient aliens, oh, but maybe there were actually ancient aliens. No. I'm not trying to invite any kind of speculation here. This is one snapshot. So I'm going to give a language and a speed up with JavaScript uint8 arrays as the base, because JavaScript is the center of my world. So. Okay, so we have JavaScript here. C++. Any takers? Is it going to be faster or slower?
Faster.
How much faster? Do we have 2 times faster?
I say 3.
3 times faster?
To
Okay.
the int8? What are we comparing it to?
It's like an auction. Okay, we get 4. Okay. 10. We have 10. Oh, wow. Okay. Okay, so we think 10 times faster.
10 because JS is in the VM and there's tons of other stuff.
Remember, I didn't count GC.
What exactly
Okay,
are we
that's
counting?
unfair.
What exactly are we counting?
Only the steady state performance.
Steady state performance.
Yes, this is the live, all the Java benchmarks. They always after you run the VM for 40 minutes and then tune your garbage collector very carefully on your workload, then look at how fast it is. This is one of those. It's the steady state performance here, not the total execution time.
And it's the int8 one, right?
Int8, yeah.
Okay.
Int8, we're not measuring GC, steady state performance. JavaScript has been handed every potential win here. This is not what it's going to look like in your app. So we have 10. We have 5. We have 3,
2 to 10 times.
2. Okay, is anyone gonna say less than 2? Okay. I measured 3.5.
Oh!
Yeah, like I think if we took like the RMS of the group's guesses here, it actually would have been like maybe someone wants to do that math right now, but like I think it actually is pretty close to the correct answer. The wisdom of large groups. Okay, Rust. So we know C++ is 3.5 times faster. Is Rust going to be 3.5 times faster? And you think
It's usually the same speed as.
Yes.
okay, so we have some people saying 3.5. Does anyone think Rust is going to be a bit slower? Do we have like say 2 times faster? 3.2?
Pi.
Pi.
I like that.
Okay, 3.14. Okay.
I'm gonna go over 4.
Oh, you think Rust is going to be faster?
Yeah.
I
Okay.
guess it's faster only because
Oh,
you're going
'cause
down to
probably
less
can
than
you-
you
Well,
right?
it's very memory safe, and
Well-
it rated really high on efficiency for power efficiency. So like to get that low level once it's compiled, I would say it yields speed and performance.
Depends though if the optimizations have been triggered.
Alright, so it says.
Yeah, but like that's what.
Let's do it.
2.6.
Ooh.
So Rust was slower.
Slower.
Not zero cost. Not zero cost.
Not zero
Why
cost.
was it that
Okay,
way?
so I
You
love
said
Rust.
earlier not to generalize from this, though.
I love
We're
Rust,
gonna look at your code.
but like
Can we actually do it at GitHub? Because I will
Yep.
definitely do that.
I'm curious. Like so, this is the thing. Like I actually, when I originally ran this, I learned the hard way that to turn on optimizations in Rust, it is not O3. I did O3, and it just kind of worked, and I was like, okay, then it must be that, right? But then no, it actually just like I had a previous compiled version of the Rust binary, and then it generated the file in the output file called 3. So I originally had Rust as being 15 times slower, and I had to like reach out to someone. I'm like, there's no way this is true, right? Okay, so yeah, 2.6. It seems like it's a little slower, but I mean, it's also less mature. Like I don't know. I think like I don't want to generalize too much again. I think the one thing we can definitely say though, like C++ just never, C++ is never the slow one, right? Like. So I don't want to be unfair to Rust, but also like yes, no one's ever complaining about C++'s performance. No one's ever picking a benchmark where C++ is slower. Like, it's,
Unless I write it.
I can, yeah, I can write a slower C++ code.
like I think there's like what like the .NET folks when they were introducing C#, they did a benchmark of like allocating like 1 million array elements or something, and they're like, look, it's so much faster than C++. But then they didn't time the GC afterwards. So.
That was the billion row challenge as well when they iterated over billion rows.
So speaking of that, Java. What do we think?
Yeah.
Java. Okay, first of all,
1.5.
you think it's gonna be 1.5 times faster?
Yeah.
Okay, we have 1.5.
Sounds reasonable. Yeah, that sounds pretty good.
You think it's gonna be 2 times faster?
Only 5.
Okay. So we have 1.5, we have 2 times faster, but everyone's in agreement it's one of these. It's like somewhere in this range. That's incredible, folks.
Nice.
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 Okay, Swift.
Oh, Swift language.
Ooh.
First of all, does everyone know what Swift is?
Okay, so Swift versus Kotlin. Like, Kotlin's upset so many things that Swift has done recently. Oh,
2 times faster?
Yeah, 2.5.
2.5 times faster?
I'm going 1 because.
You're going 1?
I
Okay.
feel like it's like 2 times.
You think 2 times faster?
Because,
Yeah.
like, doesn't it compile it to Objective C? Which, by the way,
No,
still
it actually doesn't.
No.
But
It doesn't.
but it does have Objective C support.
Right, it has
to
it.
cross compile itself.
But
But those are the Swift APIs are getting more and more.
Wow.
So there's less and less Objective C
Wow.
being used.
Wow. Amazing.
So the whole reason why I even did this in the first place was because WebKit is adopting Swift in a bunch of
Oh.
places. Not like I think out of all the projects that I've seen do some kind of memory safe adoption, I think that they're like probably some of the most reasonable people. They have a very pragmatic approach to how to do it. Very pragmatic, very reasonable. But
You know what?
I am off base.
Yeah.
so this one here, I'm like convinced I did something wrong.
Maybe.
But I asked, and folks were like, yeah, that seems about. So I really hope that someone here is going to look at this and they're going to figure out that I like used the wrong compiler options or something. I don't know Swift. They're going to figure out that I did something really silly and that it's actually more
Use link
reasonable.
through GitHub at the end of this.
Yeah. So I'll share it on Slack. But yeah, like it was. This was the whole reason why I even included this section. I wasn't going to include it. Okay, PyPy. Does everyone know what PyPy is?
Ooh. Yeah.
PyPy is a Python JIT. It's a tracing JIT. It's really cool. It's incredible. The people who work on it are really cool. I've met some of them. Has anyone used PyPy?
Technically.
A long time ago.
A long time ago.
And then you run into issues, none of your libraries worked with it.
Yeah.
They think substantially. You're like, another day.
Yes, I don't know much about Python, so I didn't try it with like truffle or whatever, like the I think truffle's the Ruby one, or like anyway the GraalVM JIT. I didn't try the GraalVM JIT, so maybe that would be different. But PyPy, slower, faster, what?
Slower.
You think it's gonna be the same as Swift? Okay, so we have 3.8, 4x slower.
I'm just guessing it will be slower.
I find this
So okay, I'm gonna throw some shade on PyPy here.
Whoa.
Wow.
But it's not. I don't think it's their fault, right? Like Python, the language, like there's all these like C bindings and stuff. I don't know. It's hard. Okay, Python itself, just using C Python.
Well,
Way slower.
yeah, it's faster, like 15 times slower.
15 times slower.
Like 30, dude.
30 times slower.
Oh, yeah.
I think that was
16.
16 times slower.
What for C Python?
Yeah, for C Python.
That's a bastardization, so I don't know.
0.05 times faster.
You think it's gonna be faster than JavaScript?
I mean, 0.05.
So 2 times slower.
0.05.
Oh, okay. So like, what is that? Math.
20?
20x.
slower.
This is where everyone realizes that I'm terrible at mental math. 20x. Okay. Okay. Do we have 50x slower? Anyone?
Why did you say that?
Going twice. 50x slower? No one thinks it's gonna be 50x. 50. I don't have any takers for 50.
Oh!
Yeah. So that one, like, I mean, like you feel it, right? Like you just it lags. Like, oh my god. Okay, Ruby. Just like whatever the standard. Like I just like.
So they're
Ruby don't.
200 times slower.
I like your
We just went from like, oh, it's not going to be that bad to 200 times slower. Okay, so we have 200 times. Okay. 70 times slower. Do we have 70 times slower?
Plus or minus 100.
That's good.
Plus or minus. Okay, 78. So, whatever. It's the same. Like, so yeah. I mean, I'll give you some takeaways because, like, I don't know. There's some random information here. I feel like I have to like tell you something. But the biggest thing. This is the first time I'm introducing this concept, but it's really important. If you're not going faster, you're going slower. So I think performance measurement is really important because every time you add a new feature, you're always risking that you add one of these new behaviors. If you tomorrow pushed a change to your front end that threw the engine off a performance cliff, would you be able to know? Like, if you're not measuring it, you'll never know, right? And the thing is, you see that even one of these odd random mistakes can make it, even in V8, in the best case, it was still 2.5 times slower because you made a mistake, right? So that's, maybe it doesn't really matter, but like 2.5 times is enough, right? Like, I don't know, you might be able to notice it. So if you're not going faster, you're going slower. You always have to defend performance. The best performance offense is a good performance defense. This is life advice. It's advice for crossing the road. It's advice for relationships. It's advice for. It's just great advice.
That the JavaScript guy is the one saying it.
You see, JavaScript added a certain amount of chaos to the universe, and then now I just have to deal with it. I mean, I'm employed because of it. There'd be no one would employ me to make it faster if it was like not this hard to optimize. Yeah, I mean, it's kind of great that like JavaScript is so fast, considering like it's not like. It's literally just like a political thing, right? Like people just threw money at the problem and now it's faster. So, it also makes you kind of wonder, like I feel like if we would have been having this discussion 15 years ago, there'd be like some like, neckbeard saying like, oh, C++ is the best, JavaScript will never be fast. You'll never be able to come within, 3 or 4x the performance of C++. It's like, well, no, I mean, you can just throw money at the problem. Sometimes you can just throw money at the problem.
It's coding labor.
Yeah.
It's genuine labor, and it's always about efficiency.
Yep. So great life advice: throw money at the problem, and it's great. And measure your specific workload, because again, this doesn't generalize. So don't assume anything. Like, I'm pretty sure that if you try to write an app and you care about like startup time, like of course Swift is going to be way better than JavaScript, right? Because I threw it because it was surprising, but you have to measure your specific workload. You have to don't be afraid to measure your workload and to pick a tool based on that. Measuring things is hard, but it's better than not measuring them. and of course JavaScript is awesome. I don't. It's come on, it's 78x.
Yeah.
Faster than Python.
It's,
78.
It's
That's
very
awesome.
ubiquitous, like, there's
So
much
how much
it
of
can-
that was because Python, and I don't know anything about Ruby, was running JavaScript as you went through it? Because with your JavaScript benchmark, didn't you ran the garbage collector before, turned it off while you ran it, and then ran it afterwards?
So this is definitely a fair point. Like, yeah, I don't have the technology to turn off the GC. I think the Python version of the script, you could, I'll upload them all after. But
other languages had GC turned on.
other languages have GC turned on because I don't know how to turn it off.
Okay, that's
so
a big
It's
issue.
definitely a thing. I think there was at least one of the languages where I was able to get it to work. But like,
Python's
for
just
example,
preference down
Python
the-
didn't have the GC.
It also has a GC.
It's got the cycle collector.
No, I
It's
did
got
GC
both,
dot
yeah.
collect. I did GC dot collect. It's fine. Yeah. Yay, ChatGPT.
Yeah.
Did you run it through NumPy?
I did not. It's possible that with NumPy it'd be way
Ooh.
faster.
Using NumPy for like interarrays, that would be way different. Like,
Yeah, it would be super.
but now you're leveraging specific, like language-specific things that.
It's still Python.
Like,
Well, but that's
Still
the
Python.
argument for Python often is that you get access to the simplicity of the glue code. That's why it uses glue code, because
Yeah.
you don't, and then when you hit a spot where it actually is a problem running, then you drop back to Fortran.
yeah.
Yeah.
So okay, Python did do collection. Java didn't. I don't know how to do it. But Java was also like, I don't know. I feel like Java already won. Like Java already won. Like, it's fine.
Yeah, it's all managed language or Java, so it's fine.
Yeah.
I'm wondering about like C++. Do you have memory leaks in that?
Yeah, I wonder. Yeah, if you don't count the time to destruct it. But let's see here. So with the C++ version, I originally wrote it by hand idiomatically, and it was like actually even faster.
Nice.
But then I'm like, okay, I can't. This isn't fair to C++ because I know C++. I don't know any of the other languages that well, right? So it's not fair for me to write it idiomatically. So I ended up going and I forced it to do heap allocations. So because the thing is, if you just do it statically, then C++ just like there's no comparison. It's 8x faster. Like there's no comparison. And same thing in Rust. Like if you allocate these arrays statically, Rust also does all the
what did you do
Cindy
with
stuff.
Rust?
Pardon?
Did you like use Vex? What did you use in Rust?
I just use Vex. Yeah. I did.
Okay.
Yeah. Well, ChatGPT just
ChatGPT used
used
Vex.
Vex. I mean, I feel like on the one hand, it kind of like adds noise because it's like
Oh, good gosh.
I don't know how to write. Like it might be really terrible, right? So it might not be like if it was idiomatic, maybe it'd be faster.
Vex rules, eh?
But yeah, so I mean, it's passing in slices. As far as I know, I was assured that passing in slices should not be doing any copying under the hood or anything like this. So we have some slices here. We have some Vex, and yes, I can confirm that if you allocate this memory statically, then it does go a lot faster. It seems like it can figure out the bounds of the arrays, and then it SIMDifies everything.
Yeah.
But only if it's static, which to me, like, sounds wrong. Like, I don't know. I would be more than happy. Like, why can't I just like import JIT and have it do this stuff for me? I don't know. I feel like even ahead of time compiled apps could take advantage. We need more JITting. I need more.
Like profile guide.
Yeah, I need more potential clients to pay me to do JIT. That's the answer there. Yeah. Any questions?
What's your opinion on SvelteKit and how they compiled their languages prior?
I have literally no clue what that is.
Okay, never mind.
What is it's a Svelte kit?
Yeah, SvelteKit. It's
like
to speed up.
Next.js.
Yeah.
Svelte's version.
Yep. It's like Next.js, but it's meant to compile everything prior to make it faster.
To like machine code or
Yeah, effectively.
but it's JavaScript.
Yes. Yeah, you would write it like Next.js.
I would guess that this is going to be way slower. The reason is that you need all this type information. I think if you had, I've even been told the same thing about TypeScript. Like the TypeScript types aren't like enough to be able to really do good ahead of time compilation. That being said, there was a really cool paper. There's a runtime called Pop. What it does is with a couple changes to the JavaScript language, so that you can't extend classes. Like if you have classes that can't be extended with like just prototype chains and all this stuff. Like if you disallow those, at the language level, then you can compile to ahead of time machine code and be approximately as fast as V8 in a scaling way. I don't know. There's like, I think the thing is essentially it's hard because V8 has a lot of money behind it, JSC, whatever. Like there's just a lot of money, right? Like people just spend a lot of time making it faster. So you can't compare that to like one researcher in Switzerland and say, oh well, the idea must be bad because it's slower. But it seemed like it could kind of do it, but you do need some changes to the language to make it work. I wonder if folks would have more ambition to change the language, then maybe we could get these use cases, and JavaScript could be used in even more places. But then again, maybe it's good that it isn't. Maybe, I don't know.
I think we have a question in the back here.
Let's do it.
Oh, it was just a silly question where I was wondering if you ordered the comparison chart from fastest to slowest on purpose.
Yes.
Yeah, because I noticed the pattern about halfway through, and I was like, okay, it's gonna be slower. And then every time I was like, oh, it's confirming the pattern.
Yeah.
Forming a heuristic. Yeah.
But then it makes sense that you would order it.
Yeah, I liked it. I thought it was fun. I don't know.
Any other questions? I think we should all give a warm round of applause to Jeff.